This is section 10.1 part B, confidence intervals for P1 minus P2. When data comes from two random samples or two groups in a randomized experiment, the statistic of p hat 1 minus p hat 2 is our best guess for finding the value of p1 minus p2. We can use our familiar formula to calculate a confidence interval for p1 minus p2. And to do that, we're just going to do our statistic plus or minus the critical value times the standard deviation of the statistic. When the independent condition is met, the standard deviation of our statistic would be the square root of p1 times 1 minus p1 all over n1 plus p2 times 1 minus p2 all over n2. Because we do not know the value of our parameters p1 and p2, we replace them with the standard deviation formula with a sample proportion. The result is the standard error, also known as the estimated standard deviation of the statistic p hat 1 minus p hat 2. So because we don't know the parameters for the entire populations for populations 1 and 2, we are going to use the standard error formula instead. If the normal condition is met, we find the critical value z star for the given confidence level from the standard normal curve. Our confidence interval for p1 minus p2 is therefore the statistic plus or minus the critical value times the standard deviation of the statistic, or in our case, p hat 1 minus p hat 2 plus or minus our z star times the standard deviation of that statistic. This is often called a two-sample z interval for a difference between two proportions. So when we have a two-sample z interval for the difference between two proportions, we can do this when the random, normal, and independent conditions are met, and an approximate level C confidence interval for P1 minus P2 will be given with the following equation, where Z star is the critical value for the standard normal curve with an area of C between negative Z star and positive Z star. For the random, the data are produced by a random sample of size N1 for population 1 and a random sample for N2 for population 2, or by two groups of sizes N1 and N2 in a randomized experiment. Remember to check the normal condition. This means the number of successes and failures for each group must be at least 10, and the independent condition must be met. So both samples or groups themselves are individual observations, and each sample or group are independent. When sampling without replacement, check that the two populations are at least 10 times as large as the corresponding samples, or check the 10% condition. As part of the Pew Internet and American Life project, researchers conducted two surveys in late 2009. The first survey asked a random sample of 800 U.S. teens about their use of social media and the internet. The second survey posed similar questions to a random sample of 2,253 U.S. adults. In these two studies, 73% of teens and 47% of adults said that they use social networking sites. Use these results to construct and interpret a 95% confidence interval for the difference between the proportions of all U.S. teens and adults who use social networking sites. So this is going to be a four-step problem. Our first thing we're going to do is our state. So our parameters of interest are P1 is the proportion of all U.S. teens who use social networking sites, and P2 is the proportion of all U.S. adults who use social networking sites. We want to estimate the difference of P1 minus P2 at a 95% confidence interval. Now for our plan, we need to start by saying what method we would use, and then we need to check our conditions. So we would use a two-sample z interval for P1 minus P2 if the conditions are satisfied. Our first condition is random. The data come from random sample of 800 U.S. teens and a separate random sample of 2,253 U.S. adults. Now we're going to check our normal conditions. So we're going to find our number of successes and number of failures for each group. Remember, to find the number of successes, you're going to take the sample size times the probability of success for the group 1 and the sample size times the probability of failure, or 1 minus the probability of success for group 1, and we're going to get 584 and 216. If we do the same thing for the adults, we're going to get 158.91, which we would round up to 1,059, and the number of failures is 1,194.09, which we would just round to 1,194. This is because the number of successes and number of failures do have to be whole numbers. You can't have a part of a failure. But all of these values are at least 10, so the normal condition is met. Then we're going to check for independence. We clearly have two independent samples. One is of teens and one is of adults. Now within those independent samples, we also need to check the 10% condition. Since they use without replacement, we have to check to make sure that the sample size is less than 10% of the entire population. So 10 times 800 would be 8,000 US teens. We know there's more than 8,000 US teens in the United States. And 10 times 2,253 would give us 22,530 US adults. And we do know we have more US adults than that in the entire country. Next is the do, where we're actually going to do the calculations. So we know that our sample size for population 1 is 800. We know the probability of success for that sample is 73. We know the sample size for the second population, or for the adults, is 2,253, and their probability of success was 47. For a 95% confidence interval, we will use the critical value of z star is 1.96. Now remember, if you don't remember how to find that critical value, if we have 95% of our data falls in our critical value, that leaves us 5% for the two tails, or 2.5% on the left and 2.5% on the right. Now that 2.5% we would actually write as 0.025, and we would look up that area of 0.025 on table A, or your Z table, and that's going to correspond to a Z value of negative 1.96. So this means our Z star value is 1.96. So our 95% confidence interval from P1 minus P2 would be given with this formula. We're just going to plug in all of our values. So we're going to do our P1 minus our P2 plus or minus our Z star times the square root of the probability of success for population 1, which was 73%, times the probability of failure, or 1 minus the probability of success, which in this case is 37%, all over our sample size for the teens, which was 800, plus our probability of success for adults, times the probability of failure over the sample size. That would give us 0.26 plus or minus 0.037, or our interval will go from 0.223 to 0.297. The last thing we would need to do is write our conclusion. So we are 95% confident that the interval from 0.223 to 0.297 captures the true difference in the proportion of all U.S. teens and adults who use social networking sites. This interval suggests that more teens than adults in the United States engage in social networking by between 22.3 and 29.7 percentage points. The researchers in the previous example selected a separate random sample from the two populations they wanted to compare. In practice, it is common to take one random sample that includes individuals from both populations of intersect, and then to separate the chosen individuals into two groups. The two sample Z procedures for comparing proportions are still valid in such situations, provided that the two groups can be viewed as independent samples from their respective populations of interest. This is an important fact about these methods. Now we can use our calculator on a TI 83 or 84 to construct a confidence interval for a P1 minus P2. We have all of our following information. So if we need to find the 95% confidence interval, to do this you would hit stat, then you would choose test, and you would choose option B, which is a 2 proportion Z interval, and then you would enter all of your values. So you need to enter the sample size for population 1, the number of successes, the sample size for population 2, and the number of successes. You're going to highlight calculate, and then you'd press enter, and it will give you your interval. So let's check our understanding. Are teens or adults more likely to go online daily? The Pew Internet and American Life Project asked a random sample of 800 teens and a separate random sample of 2,253 adults how often they use the internet. In these two surveys, 63% of teens and 68% of adults said they go online every day. Construct and interpret a 90% confidence interval for P1 minus P2. So for this problem, we need to start with our state. Remember, you need to define your parameters and you need to state the confidence interval of what you are trying to find. So our parameters of interest are P1, the proportion of all U.S. teens who go online every day, and P2, the proportion of all U.S. adults who go online every day. We want to estimate the difference of P1 minus P2 at a 90% confidence interval. Next is our plan. You're going to start by saying what method you will use, and then you will check your conditions. So we should use a 2-sample z-interval for P1 minus P2 if the conditions are satisfied. The first condition we're going to check is random. The data come from a random sample of 800 U.S. teens and a separate random sample of 2,253 U.S. adults. Next, you need to check your normal condition. And to do that, because these are proportions, you are going to find the number of successes and failures in each group, and they should all be at least 10. Next, we need to check independent. We clearly have two independent samples. One is of teens and one is of adults. The individual responses in those two samples also have to be independent. So we do need to check the 10% condition. We can guarantee there's at least 8,000 U.S. teens and at least 22,530 U.S. adults, so the independent condition has been met. Next is the do part. We know that our sample size for population 1, or the teens, is 800, with a probability of success of 63%. We know the sample size for population 2, or the adults, is 2,253, and their probability of success, or p-hat, is 0.68. We are doing a 90% confidence interval, so our z-star value is 1.645. So our 90% confidence interval for P1 minus P2 would be given using this formula. If we plug in our information, we're going to end up with negative 0.05 plus or minus 0.0324, and that's going to give us an interval of negative 0.0824 to negative 0.0176. The last thing we need to do is our conclusion. So we are 90% confident that the interval from negative 0.824 to negative 0.176 captures the true difference in the proportion of all U.S. teens and adults who go on the internet daily. This interval suggests that more adults go online every day in the United States than teens, in an interval between 1.76 and 8.24 percentage points.